Today we're going to be discussing mixed numbers, improper fractions, and decimals. Let's go ahead and get some definitions out of the way to limit confusion. A mixed number is a number that has a whole number part, which is called the base, and it has a proper fraction part. Now the only one up here that matches that description is 3 3/4, where this large 3 is our base and 3/4 is our proper fraction. And all a proper fraction means is that the numerator is smaller than the denominator. Now an improper fraction, our next definition, is the opposite of that. An improper fraction is a fraction whose numerator is larger than its denominator. And that one would be 15/4, because we can obviously see that 15 is larger than 4. Now the other number I have up here is our decimal number, and we didn't define that because we should be pretty good by now at figuring out that we've got a decimal point here at this number. And all three of these numbers have something in common, and that would be that they have the same exact value. So even though they look completely different, they are the exact same value, and we're going to figure out today how to convert between these three. So let's take a look at example 1 here. It says convert 5 2/3 into an improper fraction, and we have a few steps to do that. Step number 1 says multiply the denominator and the base. My denominator is 3 and the base of this mixed number is 5, so I'm going to multiply these together. 5 times 3. 5 times 3 is 15. Alright, step 2 says add the answer from step 1 to the numerator, and this is my new numerator for my answer. So the numerator in the problem is 2. I'm going to add that to my answer from number 1. So I'll write 15 plus 2. That is 17. Here's the numerator for my answer, my new one. Step 3, this is the easiest part. Keep the original denominator. Original denominator is 3. So that remains my denominator for the answer, and my new numerator, which is 17, will go up on top. So 5 2/3 written as an improper fraction looks like 17/3. Now I want you to try the example problem using the exact same steps we just did. Pause the video, work out the problem, and then we'll check to see if we can match up. My answer is 25/9. I hope that you matched up with me. Let's see what happened if you didn't. Step number 1 says to multiply the base and the denominator. So that would be 9 and 2. 9 times 2 is 18. Next step, we're going to take our numerator and add that to step 1's answer. So 18 plus 7, that's where the 25 comes from. Last step says to take the original denominator and to keep it the same. So we're going to write it as 25/9. Our next problem is going to be similar, but we're going to kind of go backwards. Instead of doing a mixed number into an improper fraction, we're going to do an improper fraction into a mixed number. Step number 1 says reduce the fraction if possible. So let's take a look. 20/8. Both of those numbers are divisible by 4. So I'm going to divide both by 4 to reduce. 20 divided by 4 is 5. 8 divided by 4 is 2. So I've reduced it down to 5/2. Step number 2 says divide the numerator by the denominator using long division. That means we've got to have a long division box. Now, the number that goes inside this long division box is always going to be the numerator. So I'm going to take my 5 and plug it in. That means that the 2 stays on the outside of our long division box. And now we go through the long division process. 2 goes into 5 2 times. 2 times 2 is 4. Next we subtract. So 5 minus 4 is 1. And if you'll remember from elementary school, we used to write the little r that represented remainder, and our leftovers were written right beside it. So my answer would be 2 remainder 1. Now step 3 says use the quotient as the base. The quotient is the 2. So the 2 is going to become the base of my mixed number, which is the large number. Then it says use the remainder as the numerator. Now our remainder in our problem was the number 1. So I'm going to take that 1 and create it as our numerator. And then the last step just says keep the same denominator. My denominator was 2 to begin with, so that's going to come back and be the denominator in my mixed number. My mixed number will be 2.5. Okay, let's get you to try another one. I want you to take 28 over 6, use the steps to convert it to a mixed number. Go ahead and pause the video, and then we'll come back together in a few seconds. I got 4 2/3. Let's see how that happened. First step, I reduced and I divided top and bottom by 2 because I noticed that they were both even numbers, which means they're divisible by 2. So 28 turned into 14, and 6 divided by 2 is 3. Step 2 says solve by using long division. So I'm going to put 14 in the box, 3 stays on the outside, 3 goes into 14 4 times. 4 times 3 is 12. 14 minus 12 is 2. So I now have a remainder of 2. Step 3 says that our quotient is the base. 4 is the quotient, so that's our big number. Our remainder is our numerator. 2 was our remainder, so 2 became our numerator. And then lastly, we're going to keep the denominator. We started out with a denominator of 3 in this process, and we kept it the same. So that's where our 4 2/3 comes from. Now these last few examples, we're going to be taking our fractions and turning them into decimals. And there are 2 ways of doing this. Let's look at the first option. It's using long division. So it's going to be like the process we just completed, very similar to it. There's just a few differences. So we're going to start out with long division like we did before. So I have 129 over 5. If we're doing long division, which number is going to go inside the box? It will be the numerator, 129. Numerator always goes inside, and the denominator will be on the outside. Alright, time to divide. 5 goes into 12 2 times. 2 times 5 is 10. Time to subtract. 12 minus 10 is 2. And if you remember, if we have an extra digit hanging out here, we've got to drop it down. So 9 is going to keep 2 company, and 2 turns into 29. Process repeats itself. 5 goes into 29 5 times. 5 times 5 is 25. We're going to subtract. 29 minus 25 is 4. Now instead of using the R and writing remainder, we're wanting to write a decimal answer. So this time what we're going to do is put a decimal inside the box beside 129. And if we put it inside the box, we are also going to have to put it up on top next to our quotient. So they're going to match. They're both going to have a decimal point. After that, I'm going to add a 0 onto the end of my numerator inside the box. So I now have 129.0 inside. And what that's going to allow me to do is drop down a 0 next to the 4 so that I can keep going. And I'm going to keep this process repeating over and over and over again until I don't have a remainder anymore. So let's go from here. 5 goes into 40 8 times. 8 times 5 is 40. We're going to subtract. 40 minus 40 is 0. I don't have a remainder. 0 is a good thing. So since my remainder is 0, I can stop. And 129 over 5 written as a decimal looks like 25.8. Alright, so that's one way to solve it. We can use long division. The second way of solving a fraction into a decimal is my favorite because it is the easiest. Option number 2, use a calculator. If you've got a calculator, go ahead and get it out. Rules for calculator and decimal usage. We're always going to put the numerator in the calculator first. So you may want to write yourself a note. Numerator goes in first. And this is very important. It's not always the biggest number that goes in first. It's always the numerator, just like we did with our long division. So let me show you how to type this in. We're going to put our numerator in first. So into our calculator, we're going to type 254. Then we're going to type divide, the divide button. Next, type in 6, and then hit your equals button. And you are going to get the number 42.33333333 that just repeats over and over and over. Okay? We have a specific notation that we can use for an infinitely repeating decimal number. And you might remember what that looks like. It is a horizontal bar over that number that repeats itself. So I can write it as 42.3 repeating, and this little bar up here tells me this is going to go on forever and ever and ever. Now, whether you should write this or whether you should round depends on what your directions tell you to do. Our directions didn't say anything about rounding, so that's why I included this notation. If it had said round to the nearest hundredths place, I would have had to do some rounding like we did in our last video. Because it wasn't specific in this example, there was no need to round anything. That's going to wrap it up for this video. We'll see you in class and we'll practice these a little bit more.